we're looking at trigonometric graph, and I told you that on a trigonometric graph, the graph, or it's not only a trigonometric graph, if any graph, the graph is very useless if you get your points wrong. On a trigonometric graph, the most important thing is the y-intercept, the x-intercept, the turning points, and the period. And also, I told you that most of the few are more used to degrees, but at this level, you are going to work with more with radians, so you must be also used with radians. So today I would like to ask to sketch some graphs on cos, sine, and tan, and the rest. So let me pick a question here. My first question here is 2 sine x minus pi over 4. So once you have seen that pi over 4 there, it tells you that this graph must be plotted in radians. It tells you that this graph must be plotted in radians. The first thing, you find the amplitude, which is A. And I said the amplitude is always 2. It's always positive. Even if the 2 here is negative, you still have to make it positive. Amplitude is always a positive graph. Then, the next thing, you find the period, P. The period for a sine and a cos graph, it is 360. For a tan graph, it is 180 divided by the coefficient of the x. But here the coefficient of the x is 1. So it's going to be 2 pi, because you're making in radians, over 1, which will give us
Shut up.
2 pi. Then we look at the step. Yesterday we looked at the step as it gives us the interval we must choose. We look at the step. The step tells us what should be the interval between our points. So when it is cos and sine, it is the period. It is the period divided by 4. Please, Wazi, can you put up your mic? Wazi, can you put up your mic, please? Okay. So in this case, it's going to be 2 pi over 4, which will give us pi over 2. Then the most important one is the phase shift. the phase shift. The phase shift is going to be whatever is here equal to 0. X minus pi over 4 equal to 0. And x will be equals to, yes, Sabelo.
Dear, I'm lost here because remember I was not around load shedding yesterday. What's happening there on the first step? You said P over 4. What's happening there? P over 4.
Okay. Please, the rest will just give me about 10 minutes and 2 minutes for me to explain this to Sabelo. Sabelo, let's say a course graph. Have you seen? When you are plotting the course graph, let's say I say plot the course graph between 0 and 360. Exactly. Now you start from 0. Now your next point, is it going to be 30? Or is it going to be 60? Or is it going to be 45? Have you seen? You must get a clear interval that can give you the direct turning point of that graph. Have you seen that? So what the step does is that it gives us the interval in between our points so that we can clearly get our x-intercepts, our y-intercepts, and our turning point. You understand me?
Yes, I understand you. Oh, it's the step. The step.
Yeah, step.
Oh, I understand you.
Okay, good. So it tells us
Yes,
which interval we must choose. Have you seen that?
yes, yes.
Okay, good. Okay, thank you. So we are going to have pi over 4. So when you solve for x and you get a positive, it means that it will be to the right. So it will be the pi, it will be pi. You must write pi over 4. My step is pi over 4 right. You must write this. You must write this. Pi over 4 right. Right, like this. Now, in a typical examination situation, this will be 1 mark. This will be 1 mark. There's no mark for the step. Then pi over 4 will be 1 mark. Right will be 1 mark. So already I've got 4 marks here. Good. Once you have been able to do this, it is so easy to draw the graph. And as I told you, the graph is very useless if you get the points wrong. Important for you to know that. Okay, good. So on the calculator, um, on the calculator, you go to mode. Is that clear? Mode, and you go to table. Table. Mode and table. Then it will show f of x. F of x. What you do is that, let me start here. F of x. What you do is that you put this function, exclude the phase shift, only this one, this side, which will be f of x is going to be 2 sine x. Then some of you, it will show g of x. Some of you, it will not. Just skip g of x, press equal or enter or whatever. Skip g of x. Then your start, it will show, it will bring start. Start, we start from 0. End, we end at pi over, we end at the period here, which is 2 pi, which is 2 pi. Then the step, it will give us pi over 2, pi over 2. So you find out that if you do that, it will give you all your points very nicely, but just that maybe it will be in decimal, but you yourself must know that the first one is 0. When it's 0, you find out that your y is also going to be 0. Then the next point, you add pi over 2. So pi over 2, because the interval is pi, the step is pi over 2. So the next one will be pi over 2. Pi over 2, you find out that your calculator is going to give you 2. Then your next point will be 3 pi over 2. 3 pi, is it 3 pi over 4? But on the calculator, you find out that it's giving you decimals. It's going to give you 0. Then, or is it 3 pi over 2? No, 3 over 2 pi, sorry. No, sorry. The next one will be pi. Sorry. Our next one will be pi. When I add half to this one, you will get pi. It will give us 0. Then our next one will be 3 pi over 2. 3 pi over 2. 3 pi over 2. It will give us minus 2. Then our last one will be 2 pi. And please, let's not forget, please, because you are working in radians, before you do this, you must ensure that your calculator is in radians. It's very important. Know whether you're working in degrees or in radians. Now, because you are working in radians, before you do this, ensure your calculator is in radians, please. Otherwise, you're not going to get these answers. Then 2 pi, you're going to have 0. So, on your graph, let me start from here. On your graph, please, any questions so far, please?
No questions there.
Okay, good. Let's go on. So on your graph, it is so easy to plot your points now. 1, 2, 3, 4, 5. So we start from 0. Here will be pi over 2. Pi over 2. Here will be pi. Here will be 3 pi over 2. And here will be 2 pi. Then your amplitude will be 2 here. and minus 2 here. So when it was 0, is 0. So please, you see what the step does is that it makes you get clear points, very clear points, drawing your graph. Okay, good. Then pi over 2, we have 2. Pi is 0. 3 pi over 2 is minus 2. 2 pi is 0. Then let us remember that there is a phase shift, which is pi over 4 to the right. Have you seen that? So you see that your original graph will be like this. But this is not the graph you are looking for. There's a phase shift. So here, this point is 0, 0. So now that this point will come here, then it's going to be pi over 4 and 0. And this is the relevant point that we are going to mark. Now, this point, it is pi over 2 and 0. Now, this point will come here. Now, half plus 1 over 4 will give us 3 over 4. So here will be 3 pi over 4. 3 pi over 4 and 2. Then here is pi and 0. So it will shift pi over 4 times to this place. Then if I can guess correctly, it's going to be 5 pi over 4. 5 pi over 4. 5 pi over 4 and 0. Then here is 3. This point is 3 pi over 2 and 0. So this point 2 will shift here, somewhere here. 3 over 2 plus 1 over 4. We are going to get 7 pi over 4 and minus 2. 7 pi over 4. And this will be the relevant point that are going to be marked. 7 pi over 4 and minus 2. Then there is 2 pi. So 2 pi, it will shift pi over 4 to the right. So it's going to be, how do I put it? 2 pi plus pi over 4 is going to be, I think 9 pi over 4. It's going to be 9 pi over 4 and 0. 9 pi over 4 and 0. So you see, the interesting thing is that you are better off getting this point than drawing the graph. Because if you get this point correctly and you don't even draw the graph, you only lose 1 mark. Have you seen? If you get this point correct and you don't even draw the graph, you are going to lose only 1 mark. That is why my focus here is to let you know how to get the points correctly. After that, we can just draw our graph like this. and we can see that it has shifted to the right by pi over 4 times. Please, any questions there? Please, any questions?
Everything is clear from my side. No, it's clear,
Okay,
clear.
good. Okay, Innocent, your hand is
Sir,
up.
can you please explain the shift again one more
Yes.
time? I didn't fully understand it.
Um, Innocent, can you give me some specifics here? Like what exactly is troublesome?
I'm saying that I don't understand how. Let's say when the question say you must also include the phase shift. How do I know how to implement it in the graph in terms of it moving this take to the right or to the left? That's like
Okay, you see that here. You
where I'm
understand how we
stuck.
calculate the phase shift? Do you understand how I
Sorry?
calculated the phase
Yes,
shift?
yes, I understand.
So you see the
Yes, I
phase shift,
understand, sir.
you can get positive. For instance, if it was x plus pi over 4, I'm saying, let us say it was x plus pi over 4. I'm talking about here. If here was x plus pi over 4, you find out that x will be equals to minus pi over 4. Have you seen that? So if it is minus, then it means that it is pi over 4 to the left. So now what will happen is that you see here I have 0 because it was pi over 4 to the right. I add pi over 4 to every x to shift it to the right. So here it was 0. 0 plus pi over 4. I'll get pi over 4 here. Here it was this point was pi over 2. When I add pi over 4, I get 3 pi over 4. You understand me? So if it is to the left, then this time you subtract. You subtract. Have you seen that? So the graph can shift to the left. Am I making sense to you?
Okay, so now I get you.
Okay,
I
good.
get you right now, sir.
Okay, good. Thank you. Please, any questions again, please? Yes, Luazi.
So I want to ask that that horizontal shift does not affect the y-axis points.
No, no, it doesn't affect the y-axis. It is that a horizontal shift doesn't affect the y-axis. It will not affect the y-axis. I will show you when it affects the y-axis. But horizontal shift will not affect the y-axis. Please, any questions again? Any questions again?
Question, sir, we can move on.
We can go on. Okay, good. Now, let's look at another example, which is with degrees. Now, let's say I give you let me just pick a question from here. A minute, please. Let's say we have this. A minute, please. Okay. Let's look at this example. If I give you this example, if we have a minute, please. Mm, Okay, let me just pick another example, like 2 sine half x. If I pick this example, okay, now this example, 2 sine half x minus 60. No, no, no. Let me pick another one. Let me pick something like this. 3 over 2, 3 over 2 cos half x plus 60. So please, once you have seen plus 60 here, it means we are working in degrees. So quickly ensure that on top of the calculator there is going to be degrees. Then our amplitude will obviously be the positive value here. So it's going to be in front of the what do you call it, the trigonometry. So it will be 3 over 2. Our period, because we are now working in degrees, is going to be 360 over 2. Oh, sorry, divide by half. Divide by the coefficient of x, which is half. So our period is going to be 720. 720. Then our step will be the period over 4, which will be 720 divided by 4, which will give us 180. Then our phase shift, I'll just write it PS. Phase shift is going to be half x plus 60 equals to 0. Now, if I solve x, I will get x equals to minus 120. So please, once you have got minus, you write it like this: 120 left, 120 left, like this. Yes, your hand is still up, or it's fine. Okay, good. Then you come to your calculator. Mode. You come to your calculator. Yes, Luazi.
I'm fine, sir. I get you.
Okay, good. Then you come to your calculator. Then you just type mode and table. Mode and table. Then your f of x will be 3 over 2 cos half x. You don't bring the 60. You don't bring the phase shift. Cos half x. Then start will be 0. End will be the period, which is 720. Then your step will be 180. So once you do this, it will give you very clear points because you have x and y. So you realize that it will be like this. The first point is 0. When it's 0, you have 3 over 2. The next one plus the step, you are going to get 180. When it's 180, you are going to have 0. The next one will be 360. When it is 360, you have negative 3 over 2. Then when you add 180 again, you are going to have 540. When it's 540, you are going to have 0. Then the last one will be 720. You are going to have 3 over 2. So that is the power of the step. The step helps you to get clear points when drawing your graph. So now your graph is going to now come out like this. You draw your x. Please, before we draw the graph, any questions?
No questions, sir.
Okay, good. So we are going to have 0. Then our first point is 180. Then our next point is 360. Our next point is 540. Then our next point is 720. Then we know that our amplitude is 3/2. And -3/2. So we come, when it was 0, it was 3/2, you mark. When it was 180, it was 0. You see, you get very clear points. When it was 360, it was -3/2. When it was 540, it is 0. And when it was 720, it was 3/2. Then we can just join our points like this. So remember that here you said it is 120 left. So that means at this point, which is 0.3/2, it will now come here. And please, the distance you choose doesn't really matter. The big deal here is the point, getting it correct. The beauty or the accuracy of the graph is not relevant here. It is you getting the points correctly. That is all that matters here. Okay, good. So left, so we subtract 0. Here is 0 and 3, so we subtract 120 from 0. So we are going to get -120 and 3/2. And this is the point that we are going to mark. Then here is 180. So if I subtract 120, it will come to 60. So here will be 60 and 0. And this is the point that is going to be marked. 60, 0. Then here is 360 and 3/2. If I subtract 120, it will come somewhere here, where I will get 240 and -3/2. 240 and -3/2. Here is 540. So if I subtract 120, to come somewhere here, and it's going to be 420 and 0 and 0. Then my last point is 720. So if I subtract 120 to come somewhere here, it's going to be 603/2. 603/2. So you get your points very easily. Then you can just join your points like this. And you will see that the graph has shaped 120 units to the left, as we can see. Any questions there, please?
No questions, sir.
Okay, good. Now I would like to do one last one, and this one is going to be on the time graph. It's going to be a time graph, so that but it's the same approach, but just on the time graph, the period is 180, and the step you divide by 2, not by 4. So a time graph. Let us say I say y. equals to 20 tan 2x minus pi over 6. So amplitude, please, it's very important for you to listen to. A tan graph is very different from a cos and a sine graph. The first difference that you can see is that a tan graph does not have an amplitude. Hello?
Yes, hey, we can't hear you. Yo, it's like you are very far from your mic.
Can you hear me now?
I can hear you, but it's still like you sound far.
How? I'm so can you hear me? Maybe I'm not shouting.
Hear you, sir.
Yes, I'm yes.
Yes, I can hear you.
We can
Okay.
hear you.
Okay, good. Yeah. Okay, we are going to go on. We are going to go on. Now, let us know that a tan graph has no amplitude. No matter the number in front of the trig, a tan graph has no amplitude. It's very important for you to know that. There is no amplitude. So anytime you are asked for the amplitude of a tan graph, say a tan graph has no amplitude. It has no amplitude. Then the period. This time, once it's a tan, it will be 180 over the coefficient of x. So it will be pi. Pi is 180 over 2. So it will be pi divided by 2. When it is tan, the period is 180, not 360 or 2 pi. Then our step 2, you don't divide by 4. Our step, you divide by 2. So it will be pi over 2 divided by 2, which will be pi over 4. Then our phase shift will be 2x minus pi over 6 equal to 0. X will be equals to pi over 12. So it's important for you to write pi over 12 right. Pi over 12 right. Then you come to your calculator, you press mode. You press mode and table. Now, f of x you put 20 times 2x. That will be 0. And is going to be the period, which is pi over 2. Then you realize that when you draw your graph, this time you're going to see some error on your calculator, on the table. Please, can somebody do it and let's see? And please, and here we are in radians. So ensure your calculator is in radians. Ensure your calculator is in radians. So when it's 0, we are going to have minute. When it's 0, Yaluaz, is your hand up? Luaz, is your hand up?
No, sir.
Okay, when it's 0, it's 0. We have 0 here. Then our next one will be pi over 4. When it is pi over 4, we are going to get error. Can you see that? We are going to get error. That one should tell you that anywhere you are getting an error is an asymptote. Anywhere that you are getting an error is going to be an asymptote. Then our next point is going to be when I add pi over 4, I will get pi over 2. Pi over 2. If I put pi over 2, I'm going to get 0. So we draw our graph like this. This time, so we are going to have 0, pi over 4, pi over 2. Then we know that where there was the error was an asymptote. So, and 0 was 0. So, it means that our graph will start from here up to 0. Then it's going to go like this. Have you seen that? Then now all that you do is that this point, you just subtract pi over 4. So here is 0, 0. This 0, 0 will now come here to be, oh, it was to the right. So this one will come here pi over 4 times. This after will come here pi over 12 times. This point will come pi over 12 times. Then you just shift the graph to the right. We don't have much time, but you can see examples in the book. You just add pi over 12, pi over 12, pi over 12 to the right. Then you can draw the graph. Please, any questions? Yes, Wazi.
No, I have no questions there.
You have no questions.
Sir, I wanted to know when we talk about the phase, are we also expected when we're drawing that graph? Are we also expected to draw that shifting, or do we only write it?
You said
I'm saying that when we write the phase shift, do we only write it, or also do we plot it in the graph?
yes. Once you draw, you must put the shift. You must show that the graph is shifting.
Okay, thank you, sir.
Okay. Any questions again? Any questions again, please?
No questions, sir. Can you please continue?
Okay. So our next thing we are going to do is we are going to look at how do I put it? We are going to look at the sine rule and the cosine rule. We are going to look at the sine rule and the cosine rule. We are going to look at the sine rule and the cosine rule. Now, if we can look at this thing, how do I put it? The sine rule and the cosine rule is needed if we don't have if our triangle is not a right angle triangle. It is used to calculate the sides. And the sine rule and the cosine rule is used to calculate, and for instance, if you have a triangle like this, and it's not a right angle triangle, you are going to need the sine rule and the cosine rule to be able to calculate the what do you call it? To be able to calculate the angles and the sides. So the sine rule simply states that it can be any triangle. So if here is A, you have an angle A here, the opposite side is A. And if you have an angle B here, the opposite side is B. And if you have an angle C here, the opposite side is C. So the sine rule simply says that if like you pick A over the opposite angle, which will be sine A, it can be the same as B over the opposite angle, which will be sine B. Then in the same way, if you have a, for instance, c over sine c, it can be the same as a over sine a. Then the last one, if you have b over sine c, sine b, it can be the same as c over sine c. So that is all that the sine rule is saying. That is all that the sine rule is saying. That is all that the sine rule is saying. Please, any questions with the sine rule? Any questions about the sine rule? Any questions about the sine rule?
No, so far so good, sir. You can proceed from my side.
Okay, good. Then the cosine rule too says that if you take any one side, let us say a squared, it can be the same as b squared plus c squared minus 2. Let me just do it again. Like if you have the triangle like this, A, we have the angle A, B, we have B here, then C, then we have C here. So if I take one side, let us say A squared, it will be the same as B squared plus C squared minus 2BC, the cos of the angle, which is A. Then in the same way, if you have B squared, it can be the same as A squared plus B squared minus 2AB cos the opposite angle of C, which is C. Then the last one, if I have B squared, it can be the same as A squared plus B squared, plus C squared minus 2AC cos minus 2AC cos cos B. So that is all that the sine rule is saying. So once you understand this, you should be able to answer any questions there. So let us pick an example. There are so many examples in the book that you can try, but that is all that the rule is saying. That's all that the rule is saying. So most of the examples in the book has been done for you. Most of the examples in the book has been answered for you. So, but we can still look at a few examples, like if we can look at activity 8,4, 8,14 on unit. If we can look at activity 8,14 on 8,14, sorry, on page 35. It says that solve the triangle. Solve the triangle. So if we can look at the first one, it has given us question one. Question one is like this. It's like this. It has given us okay, we have A like this, B, sorry, we have this one like this. A minute. Yeah, got it. Then the question says that um B is 64,3. So here is B. Yeah? Then the angle, so if the here is B, the angle here is 64,3. 64,3. Then B itself is 135. B is 135. Then it says that C is 118. C is 118. So let us say that here, if here is C, then here is 118. 118. Then we don't know anything about A. So if here is A, the angle here is going to be A. The angle. So if that's the case, we can now look at we can now look at if you say solve the triangle, that means that you must find C, A, and the angle A. So to find C, we can say that 118 over C will be equals to 135 over sine 64. Then we can solve for C. Then we can easily solve for C. So once we know C here, we can easily find A using, we can solve for A using the no, we don't know, we cannot. Good. Once we know C, we must now solve for the side A and the angle A. We must solve for the side A and the angle A. Now, here we cannot apply the sine rule because we will have A over sine A, then so we cannot apply that one. Then here too, we cannot apply if we apply the cosine rule to there will be something deficient. So what do you think we can use here? Who can help us? How are we going to find angle A and the side A? Who is going to help us? Who is going to help us, please?
I think we can be able to find angle C first.
Yes, we have found C. That's what I've written here.
After
C.
So
Then
I
we
think
can use
we can use
do we have
the
the triangle? Can you see that?
rule.
Hello? We have to know
I
that
think we can use the
yeah,
cosine
double
rule to find A.
you said we use what?
I think the cosine rule to find point A, and then you can find the angle of A
No,
after
to use
finding.
the cosine rule, we don't know this angle. Can you see that? So we cannot use the cosine rule to find A when we don't know the angle A. You understand me?
sorry, all this angle they don't equal to 180.
He said,
When we end all these angles, they are
good,
not supposed to give
good.
us 180.
Every triangle, when you add the angles, it will be equal to 180. So we can say angle A plus angle C plus angle B is equals to 180. Then you can find C. Sorry, you know C already, so you can find A. So once you know A, then you can use the cosine rule, as you said earlier. A will be equals to B, A squared will be equals to B squared plus C squared minus 2AC. No, minus 2BC, sorry, cos A. Please, when we finish, you have to know that, remember that you must find the square root. You must always find the square root. You must find the square root. Then you can find the this. Please, any questions there? Yes, Luazi. Yes, Luazi, is your hand up?
Say,
Yes.
I want to ask that is it possible or is it correct to use
Yeah.
the sign rule again to find A
Exactly. You
because
can
I
use
we
the
have
sign rule
the
again.
angle?
Correct. Yes, it's correct. You can use the sign rule again.
Yes. Okay, thank you.
Okay, good. Please, any questions again? Any questions again? Okay, good. Now, please, because you don't have the book, it's difficult for me to not because you don't have the question papers at hand. It's difficult for me to help you with what do you call it? What do you call it? The um this thing like the more complicated questions involving sine rule and cosine rule. So now I will not say it's complicated, but then it is not straightforward questions. So I'm going to put some of these questions on the WhatsApp group. Then you try and solve them. So if you are having challenges, then I will assist you there. Would that one be fine? Hello? Can you hear me?
Yes.
Yes, I'm saying that because you don't have the questions at hand and the questions involves diagram, I'm not able to put the diagrams on the board. So please, can you go and look at the questions on, how do you call it, the class test, and also the semester test too, questions involving the sine rule and the cosine rule. And I will also try and find some and put them on black on the WhatsApp group, so that way you look at them and see whether you can be able to apply the sine rule and cosine rule to solve triangles that are not right angle triangles. Is that fine?
Yes, it is.
Okay, good. But please also remember that if you are having what do you call it? If you are having how do I put it? If you are having a um if you are having a right angle triangle, then the best you can also use the sine rule and cosine rule. The sine rule and the cosine rule also works with right angle triangles. But SOHCAHTOA, sin theta, cos theta, and tan theta, or the trig ratios and the Pythagoras theorem only works with right angle triangles. So in this case, it's a matter of applying these things to solve the questions, because you need to practice before you can be able to solve those questions. So please look at the questions on the class test, and also the questions in the um, how do I put it, on in the semester test, and ensure that you can do them. But as I am we close the class. I'm also going to look for some and put them on the black on our on WhatsApp so that you look at them and see whether you can apply them to solve them. Because the key thing is you knowing how to apply them to solve those questions. Is it fine with you?
Yes, sir. Sir, can I ask this question?
Yes.
If I use this sign and cost rule on the
Yeah.
right right triangle,
Yeah.
yeah, am I going to get different answer to
No,
those
you
of
get the no,
Pythagoras theorem?
no, you get the same answer. The same set of
Okay,
answers.
okay.
Is that fine? Okay, good. Yeah. So you can use because the time when the cosine is universal, it works with any triangle at all. Is that fine?
Yes, sir.
Okay, good. So then if in the answers of no questions, let's bring the class to a close. Let's bring the class to a close. I
So
will,
I have questions,
okay, good. What's the question?
but it's not on what we did today.
Okay, we can ask it.
So I was I was doing the referencing questions that we did. Can we
Yes.
go to activity 8.9?
Okay, let me see. Activity 8.9.
Yes.
8.9. Let me go activity 8.9. Let me place activity 8. Yes, 8.9. Yes, I'm there.
Okay. Number two, 10 negative pi over 4, right?
Yeah,
So
yes,
I understand. Okay. So I know that it's going to be in the fourth quadrant, right?
yes.
And then my triangle is 90, 45, 45.
Your triangle
This
is
round. Inside my triangle, it's 90, 45,
yeah,
45.
yeah.
And okay. So now I don't know, should we put 10 negative pi over 4 in the calculator so that we know which number, like I just don't know how to solve it from there. I know how to draw the triangle and everything, but I'm stuck as to how to go forward.
No, you have um you have here will be pi over 4. It will be like this, ne? Pi over
Mm-hmm.
4. So your ref angle, your ref angle will be how do you call it? Pi over 4. The closest one is 0. So it will be pi over 4. Positive pi over 4. Is that clear? So
Okay.
when you're calculating, use the reference angle. Can you see that? So tan, even though it's tan negative pi over 4, you know that the reference angle is pi over 4. So pi over 4 is um 1. Have you seen that?
Mm-hmm.
But
Yes.
in the fourth quadrant, tan is negative. Can you see that? So it's going to be
Yes.
negative 1. It's as simple as that.
Oh, okay. No problem. Thank you, sir. I
Okay,
understand.
okay, good. Please, any questions again? Please, any questions again?
No questions, sir.
Okay, good. So please, then we are left to going to practice. Exactly. We are left to practicing these things. Especially the sine rule and the cosine rule. And if you have any questions, you can just ask me on Blackboard. I'll do it and send it to you on WhatsApp. Then I'll do it. And send. But most of the questions there is the application of the sine rule, the cosine rule, and then SOHCAHTOA and the rest, depending on the triangle they are talking about. Is that clear?
Yes, sir.
Okay, good. So then let's bring the class to an end for today so that you have time to look at it. Is that okay?
Yes, sir. Thanks, sir.
Okay,
Enjoy
thank
your
you.
evening.
Same to
Thanks.
you. Bye.
Bye.
Bye.